Have you ever just stared at a wall of numbers and felt completely lost? Well, today we're going to fix that. We're going to turn all that confusion into crystal clarity. We are going to build a visual toolkit that transforms raw, messy data into powerful, easy to understand stories. So here's our game plan for this explainer. First, we'll talk about why we even need to organize data in the first place. Then, we'll build our foundation with something called frequency tables. After that, we'll get into the fun stuff, all the different charts for categories and for continuous data. And finally, we'll wrap up by learning how to read these graphs like an absolute pro. Okay, let's kick things off with section 1, making sense of data. This is all about taking something chaotic and making it clear. Because, let's be honest, we all start with a problem that looks a little something like this. You've done all the hard work, you've collected your data, and you're left wondering, how in the world do you turn this mess into something that actually means anything? Right now, this is just a random jumble of numbers. It doesn't tell us a story, it doesn't reveal any patterns, so what's even the point? Well, the goal is actually pretty simple, but it's incredibly powerful. We want to organize and draw this data so we can actually see what's going on. We want to be able to spot patterns, to compare different groups, and, at the end of the day, make smarter decisions based on what the numbers are really telling us. Which brings us right to our second section, the foundation, frequency tables. And I'm not kidding when I say this is your first and most important tool in the entire toolkit. So what even is a frequency table? Honestly, it's just a super neat and tidy way to count how many times something appears. Think back to grade school when you used tally marks to count things. This is basically just the grown-up, organized version of that. And boom, look at that transformation. That chaotic jumble of numbers from before is now perfectly organized in this little table. We can see just at a glance that the number 5 is the most common. It showed up 3 times. This simple table is the crucial starting point for pretty much every single chart we're about to discuss. Okay, on to section 3, charting categories and parts. Now that our data is all organized, let's start making it visual with some tools that are built for comparison. First up, the good old bar chart. Its job is to compare different, separate categories, things like favorite colors or types of pets. The rule is easy. The taller the bar, the more stuff is in that category. But here is the key rule, the one that always trips people up on exams. The bars must be separate. They do not touch. Next up, we've got the pie chart. Now, while a bar chart is for comparing separate groups, a pie chart is for showing how different parts make up a single whole. Each slice represents a piece of that total. And all the math behind every single pie chart out there, it all boils down to this one number. The entire circle represents 100% of your data, and that always corresponds to 360 degrees. So how do you actually make a slice? It's a really simple 2-step process. First, you figure out its fraction. So you take the frequency of your category and you divide it by the total number of things. Step 2, you just multiply that fraction by 360 degrees. And that's it. That's the angle of your slice. All right, let's dive into section 4, graphing continuous data. Now we're getting into tools designed for data that doesn't fit into neat little categories, but flows continuously. Things like height, weight, or time. This is a histogram. And yeah, at first glance, it looks just like a bar chart, right? But there is one huge difference. The bars touch each other. And that's not just a design choice, it's a rule. Those touching bars are a signal that the data is continuous, that it flows from one group right into the next with no gaps in between. Let's put them side by side for a second, because this is one of the most common points of confusion out there. Bar charts are for discrete, separate categories, like types of fruit, so there are gaps between the bars. Histograms are for continuous data, like height, where the values can be anything in a range, so there are no gaps. And here's the subtle but super important difference. In a histogram, it's technically the area of the bar, not just the height, that represents the frequency, and that little detail is about to become very, very important. Which leads us to this expert-level question. Standard histograms have bars of equal width, right? But what happens if they don't? How can you accurately compare a really wide bar to a really skinny one? The answer is a concept called frequency density. See, when the widths are different, you can't just compare the heights anymore. It's misleading. You have to calculate a new height by dividing the frequency by the width of that particular bar. This makes sure that the area of the bar is what's correctly representing the data. So the crucial point is this. With unequal widths, always compare the area, not just the height. Our next tool for continuous data is the box plot, and its power is really in its simplicity. It can take a massive, sprawling data set and just squeeze its entire story down into 5 key numbers. It gives you a super quick snapshot of how your data is distributed. And here they are, the 5 numbers that tell the story. You have the absolute minimum and maximum values. That's the full range of your data. Right in the middle is the median, the true halfway point. The box itself is defined by the first and third quartiles, and that shows you where the middle 50% of your data is clustered. So a short box means your data is really consistent, all packed together, while a long box means it's much more spread out. Okay, we're in the final section, reading graphs like a pro. We've built the toolkit, and now we're going to learn how to use it critically and, more importantly, how to avoid being fooled by a bad data visualization. So here's your checklist of red flags. If you see a graph with a broken axis or one that doesn't start at 0, be suspicious. It's a classic trick to exaggerate differences. If you see a histogram with unequal bars but it's not using frequency density, that's misleading. Always, always look for missing labels or units. And remember what we just learned. Never let your eyes confuse a bar's area with its height. This brings us to the expert mindset. You can't just look at a chart and say, oh, that bar looks bigger. The real skill is to be able to translate the visual back into the numbers it represents. You have to compare the distributions logically using the principles we've discussed, not just your gut feeling from looking at the picture. And so I'll leave you with this to think about. Imagine 2 box plots. They have the exact same median. That middle line is in the very same place. But one has a short, compact box, and the other has a box that's long and really stretched out. What does that difference in spread tell you about the consistency, the risk, or just the nature of those 2 data sets? What is the real story the data is trying to tell you?
Hey there, and welcome. You know that feeling when you're just drowning in a sea of numbers? Well, today we're building a lifeboat. We are going to look at the essential tools that help us find the real story that's hiding inside any set of data. Let's dive right in. So take a look at this. It's just a bunch of numbers, right? On its own, it doesn't really mean anything. Is this good? Is it bad? Who knows? See, raw data is kind of like a jumble of random words. It doesn't actually tell you a story until you know how to ask the right questions. And it turns out, to make sense of pretty much any data set, you really only need to find 2 things. First, you need a center, which tells you what a typical value looks like. And second, you need a spread, which tells you how varied everything is. That's it, center and spread. Let's break down what that actually means. Okay, first up, finding the center of our data. This is all about our quest to find one single number that can best represent the entire group. You know, what's the typical value here? What's the middle ground?
So the most famous way to do this is the mean, which you almost definitely know as the average. The absolute easiest way to think about it is like you're sharing something. Imagine you take all the values, throw them into one big pot, and then hand them out so that everyone gets the exact same amount. That amount everyone ends up with? Yep, that's the mean.
And calculating it is a super simple 3-step process. First, you just add up all the numbers. So in this case, 2 plus 4 plus 6 plus 8, that gives us 20. Step 2, you count how many numbers you have. We've got 4 of them. And finally, step 3, you divide that sum by the count. So 20 divided by 4 gives us a mean of 5. Easy, right?
But, and this is a huge but, the mean has one critical weakness. It is so sensitive to outliers, those one-off numbers that are either way, way higher or way lower than everything else. Just one of those extreme values can pull the entire average way off, giving you a really misleading picture. Remember that, because we're going to see it in action in just a little bit.
So to fight back against that weakness, we've got another tool, the median. The idea here is honestly even simpler. The median is literally just the value that's in the physical middle of the list after you've lined everything up in order. Just picture lining up a bunch of people by height. The person smack in the middle, their height is the median height.
Now, finding the median has one absolutely crucial first step. You have to arrange your data in order, from smallest to largest. If you've got an odd number of values, it's easy. The median is just the number right in the middle. If you have an even number, like we do here, you just find the 2 middle numbers, add them together, and divide by 2. So for 2, 4, 6, and 8, the 2 middle numbers are 4 and 6, and the average of those is 5.
And this, right here, shows you the median's superpower.
Because it only cares about what's in the middle position, it completely ignores any crazy extreme values. I mean, think about it. A billionaire could walk into a room and the mean income of everyone in that room would shoot through the roof. But the median income? It would barely even budge. Now that's what we call a robust statistic.
Our third and final measure of center is the mode. And this one's the easiest of all. It's just the value that shows up most often in your data. So in the set here, the number 2 appears twice, more than anything else. So the mode is 2. It's worth knowing that a data set can have one mode, it can have more than one, or it can have no mode at all.
Okay, so we've got a handle on how to find the center, but that's only half the story. To really get the full picture, we also need to understand the spread. Are all the numbers clustered really tightly together, or are they scattered all over the map?
The simplest, most straightforward way to measure spread is with the range. It just answers one simple question. How wide is the data from one end to the other? And you calculate it just by taking the highest value and subtracting the lowest value.
For instance, if your highest number is 15 and your lowest is 4, the range is just 15 minus 4, which is 11. It gives you a really quick at-a-glance idea of the total spread. But just like our friend the mean, the range has that same sensitivity problem. Because it only uses the 2 most extreme points, a single outlier can give you a massively exaggerated idea of how spread out the rest of the data actually is.
So for a more reliable, more robust tool, we turn to something called quartiles. The whole idea here is to chop our ordered data up not just in half, but into 4 equal sections. And this gives us a much more detailed picture of the spread.
So here's how it works. First, you find the median of the entire data set. We call this quartile 2, or Q2, and it splits the data perfectly in half. Then you just do it again. You find the median of the lower half of the data, and that gives you quartile 1, or Q1. And finally, you find the median of the upper half of the data to get quartile 3, Q3. And just like that, you've found the markers for 25%, 50%, and 75% of your data. And this leads us to a really fantastic measure of spread, the interquartile range, or IQR. You just calculate Q3 minus Q1. What this number tells you is the range of the middle 50% of your data. By totally ignoring the extreme values at the very top and very bottom, the IQR gives you a measure of spread that is completely resistant to those pesky outliers. Okay, so now let's see why all of this really matters. We're about to walk straight into what I like to call the outlier trap, and we're going to see how choosing the wrong tool for the job can lead you to a completely wrong conclusion. Take a look at this data set. Most of the numbers are small, right? They're all clustered together. And then you've got 100, just hanging out there, a massive outlier.
So I'll ask you, based on everything we've just talked about, what would you say is the typical value in this set? Just take a second and think about it.
If you went with the mean, you'd get about 18.7. But look, that number is bigger than almost every single value in the set. It's totally misleading. But if you chose the median, you get 2.5. Now that number tells the real story of where most of the data is actually living. That right there is the outlier trap in action.
And congratulations! You now officially have a complete data detective toolkit. You know how to find the center, you know how to measure the spread, and most importantly, you know which tool to grab for which job.
Here's a quick little guide to sum it all up. Honestly, the biggest takeaway is this. If your data has outliers, you should always lean on the median and the IQR. They'll give you a much more honest story. If your data is nicely balanced and symmetrical, the mean is a fantastic choice. Need to find the most popular item? Use the mode. And if you just need a quick and dirty sense of spread, the range works. Just be careful with it.
With these tools, you can now look at anything. Salaries, temperatures, customer reviews, you name it, and start to really uncover the hidden story. So the only question left is, what story is the data all around you trying to tell? Thanks for tuning in.